So for this next session, we've got a good mate, the CSS wizard, Harry Roberts. He's an independent web consultant and performance engineer in the UK. He's been working with the biggest brands as long as I've known him, which is about 10 years, I think we just figured out. But he helps the world's largest companies and respected organizations find and fix their site speed issues. He's been the expert on this as long as I've known him. He's worked with all kinds of organizations from the UN to the BBC, General Electric to the Financial Times. He's a Google and Cloudinary Media developer expert, all-around good guy, even when he's not riding his bike and as much as he should. We're going to have to do that together one of these days. Welcome to the stage, Harry Roberts.
Dude, thank you so much, man. That's wonderful. All right, yes, thank you. It's interesting. So I've been doing this, Jason said, like a long time. I've been speaking for about 12 years. And it's mental. Today's the first time I've ever seen 2 cache control talks in one conference. Never mind one day, one conference. So if anyone saw Matt's talk this morning, he gave a really, I think, very good introduction to how to actually set cache control headers. Ideally, if I could have chosen to do our talks the other way around, I would have done. Where Matt's talk was a very approachable sort of intro to setting cache control headers and caching strategies. My talk is more of the theory of what should those numbers be? What should your caching strategy actually be? You need to know that before you start putting your cache control headers live. So what I'm going to do is do a full talk on the humble HTTP cache. We might know it as the browser cache, but generally we just call it the HTTP cache. So a quick, honest, actually, do you know what? I've got a little story to tell you. I was going to say this. I forgot to say this. This isn't my first time at Web Unleashed. I was here years ago. It's really good to be back on stage, really good to be back in Toronto. I really am fond of this city, the food, the drink, the people. Who's from Toronto? Most of, but not as many as I expect. Who's Canadian? You folk cannot shake the stereotype, can you? I held the door open yesterday, and the guy didn't say thank you, he said sorry. That's how, if I just woke up and I had to work out where am I, I'd do something like that, and if someone said sorry, I'm in Canada. But yeah, so it's really great to be back, and I'm going to be doing, like I say, a full talk on browser caching, cache control, a fairly theoretical talk. As I said, it goes really nicely with Matt's more practical talk. But what I do want to quickly do is just get an honest show of hands. Who feels they've got their caching strategy nailed? Who thinks they understand cache control headers really well? That is an honest show of hands, thank you. Well, hopefully you'll get some value out of the talk then. Again, honest show of hands, who thinks caching headers are sometimes contradictory, a little confusing? It's hard to know that, does this header work with this one or against it? Are they complementary or not? Certainly me, I definitely, until I started researching this topic deliberately for a specific client project, I didn't know which 2 headers might collide, what might be a net worse sort of effect than doing nothing at all. There are so many different headers. Are they duplicates? Are they equivalent? Are they redundant? Do we need all 5, or do we just need a subset of them? So this talk aims to distill and demystify all of that so that hopefully at some point we can write our own strategies and just have a really dialed-in caching strategy. For those of you in the room who think, oh my god, an entire talk about cache control, that sounds so boring. Yep. So I won't do much of an intro. Jason did a really good job already. I'm Harry. I'm a consultant performance engineer from the UK. I tend to work with fairly large companies. One thing I like about this talk, though, is it doesn't matter if you are million active monthly users, software as a service, or if you are just building a website for your cousin's restaurant. Everyone can benefit from having a decent caching strategy. It applies to all websites just the same. There's a saying in my industry that the best request is the one that's never made. And it's certainly true. It's faster to do nothing than it is to do something. However, I genuinely believe there's a huge over-focus in my industry, the performance industry, to just look at first-time visits, like the most pessimistic scenarios, cold cache scenarios. Out of the box, like a web page test, it can give you a repeat view, but it visits pages from the worst possible conditions. Lighthouse tests always have an empty cache. But what happens if we've got a primed cache? Whatever hundreds of milliseconds it took to fetch your CSS could become 0 if we just get things right. And that's why I think it's an important thing to focus on. I think the reason people don't focus on it enough is that it's just not very exciting. It isn't. And also, it's not particularly straightforward, and that's exactly why I've written this talk, to try and make it a little more palatable. Before we go into the actual nuts and bolts of what our caching headers and strategies and what numbers we should pick, I want to just sort of solidify some key concepts. I think it's going to be quite important that we all have a shared understanding of certain key terms, key concepts. A lot of you will have heard these phrases before, so I don't want to patronize you. It's more that we all understand them as meaning the same thing. So the first concept I think we should look at, caching and revalidation. It's kind of a fairly obvious starting point in my opinion. Caching and its sister topic, revalidation. Not cache busting, we won't, like there's no, well actually, we'll see later in the talk, there isn't really such thing as cache busting as we think we imagine it. But caching and revalidation. Caching is simply how long can I reuse this file without checking for updates. There's a really important subtlety to this sentence, and it's without checking for updates. This is a really key, important point that I think leads to a lot of confusion. A lot of people skip over or don't really understand the importance of this bit of the phrase. We'll come back to that in a second. Revalidation is how do I check that a file has changed after that cache time limit is up. So again, the important bit here is after the cache time limit is up. Purely anecdotally, a phenomenon I see all of the time when I work with engineering teams is this huge misconception that you can somehow have a cached file that is always the most up-to-date. And I think a lot of developers don't realize that by picking a caching strategy, you're opting into the complete opposite. If you choose to cache a file, you have to accept that for some users, for some period of time, it will be out of date. Having a cached file that is always up to date is virtually impossible. We can get close, and we'll find out how, but one thing that I find developers either frustrated with or confused by is the kind of expectation that, well, I want to cache a file, but I need to give the newest version of the file to the browser as soon as it's available. It's like you can't have both, and it's a very important distinction. The simplest way of kind of proving this to developers is just with a simple truism. Caching is a way of stopping the client speaking to the server. So you have to accept that if you've told a file to be cached for a week, but you change it after 1 hour, a user might see the old file for 6 days and 23 hours. If you pick a caching strategy, you are opting into potentially serving stale content, and that's why it's so important to be very mindful of the numbers you choose. As a result of this, another thing that I think a lot of developers should be aware of but aren't, is simply that revalidation should never be happening while a file is cached. If you've told a browser to cache a file for a week, other than a hard refresh, there is no reason that browser should ask the server for fresh content for the entire duration of that week. If you see revalidation happening while you think a file should be cached, you've probably got a configuration error, a conflict, or a bug. I've seen this quite frequently where people think they've set the caching headers correctly, but they're also omitting certain other headers that just sort of negate that work. Next concept, fresh and stale. When we talk about responses, we talk about fresh responses, stale responses. So fresh is a file that is in cache and within its expiry date. It doesn't mean it's the most up-to-date version of the file. It just means that it's still got some time left that it can be reused from cache. The flip side is stale. The file is in browser cache, but the max age has been reached, and now it needs to be revalidated against the server. This file is stale. There's a third scenario that isn't covered by fresh and stale, and that is the file that is on the server that is more up-to-date than any files in the cache. There isn't a name for that. In the caching world, there isn't a name for that. If a file is on the server, it's probably the most up-to-date, but it doesn't necessarily mean it's in cache, so fresh and most up-to-date are not the same thing. And again, this is a simple sort of concept that I really try and drill home. This is probably the most patronizing for a room full of developers, request and response. We probably all know what a request and a response is, but I kind of want to point out a slight hypocrisy of my own here. I've kept saying the word file. Technically, what I should be saying is response. We could get a 404 response, which is literally the absence of a file. So what I'm going to try and do for the rest of the talk is I'm going to try stop using the word file and start using the word response instead. A simple request-response mechanism might look like this. Client goes to a server, gets a response back. That will have a response code. At this point, it's not relevant. At this point, it's relevant. When we look at response codes, the only two we care about when we're debugging our caching strategies are 200s and 304s. Forget any other response code. If you're debugging caching, these are the only two you care about. 200 is simply, yes, I fetched this file, everything went fine. I've done it already. I fetched this response, and everything went fine. 200s are good. A 200 could look like this. A request goes out, hits the server says, yep, I've got that thing you need. Well, in this case, it probably would be a file because it's a 200. Have it. And it comes with a 200 code. There is a subtly, well, not even subtle, there is a different scenario in which you will get a 200, which I don't particularly like. I wish there was a different response code for this. But if a file is in cache and considered fresh, the browser doesn't go across the network at all. It just goes straight to its cache. If the file is still usable, it releases it. That still has a 200 response. So it makes it a little more difficult to debug whether a file came from cache or origin or the network. They both carry 200 responses. A 304 is, I went to the server and I checked, and the server said you can still use this file. You can still use it. So a 304 response would happen if a file has expired, it's gone stale. The browser then says to the server, hey, look, I've got this file, but it's gone stale. Can you let me know if I'm allowed to reuse it? If the server says, yep, I've got no changes here, you're still safe to use the copy you've got, what happens is the response comes back, just a header. It sort of renews the cache policy and then pops that file out of cache. This time it comes out of cache just like the 200, but you'll see a 304 response. Every 300 class response is just a redirect, so you can think of a 304 as redirecting someone back to their own browser cache. All right, key concepts done. Let's look at something that I like to do with any kind of problem I solve, is just to remove the problem. The simplest way to solve a problem is just get rid of it. So let's start with the delete key. Let's get rid of some stuff. The headers we don't want. When I first started researching caching, it was for a very specific project a couple of years ago. When I first started researching it thoroughly, my first job was to work out, of all these headers, are there any I can just get rid of? And it turns out most of them. Pragma. If you've got a Pragma header, get rid of it. If your browser, or your web server is omitting or emitting a Pragma header, just get rid. It probably looks like this, Pragma no cache. None of these headers are particularly harmful, they're just unnecessary and noisy. Pragma was actually, it's a kind of caching header. It was never defined to be a response header though. Pragma was never meant to be used for responses. It was a request header for H1.0. For backwards compatibility reasons and sort of paving the cowpath, people in H1 started using it wrong, so H1.1 allowed it to be used a bit differently, or rather, sort of implementers allowed it. What you'll see is the spec say that Pragma is not actually specified for responses, and therefore is not a reliable replacement for cache control. So if you've got Pragma, first thing I would suggest is just get rid of it. It simplifies things. The next thing to get rid of might surprise you. It's the Expires header. The Expires header is incredibly common. It just looks like this. It's a response header which has an absolute timestamp in the future, hopefully in the future. If it's in the past, it basically means you can't cache this file at all, which therefore brings, well, I'll come back to it later, but that poses an interesting problem. An interesting issue with the Expires header is that if you roll a release and you say this file expires in a week, then you go on vacation for 2 weeks and your web server, all of a sudden, the actual current day tips past your Expires header. While you're on vacation, not deploying, not doing anything, all your Expires headers are now 1, 2, 3 days in the past. You're permanently just cache busting your entire site. So that's why we don't like Expires. Expires is also not extensible. So yeah, it's a caching header. Again, it's not really harmful. The good news with Expires is if there's a presence of cache control anyway, the browser will just ignore the Expires header. The browser and all intermediate caches as well. So again, it's not harmful, but in the sake of being clean and just tidying up, get rid of Expires headers and use cache control instead. It even says in the spec, if there is a cache control header with a max age or smax age, Expires is ignored. So again, it's not harmful and it will just be discarded, but we might as well get rid. One way I like to think about it is cache control does everything Expires does and way more. One of the primary benefits of cache control, extensible by design. This one might surprise you as well. Last modified, we can get rid of this. Last modified isn't our preferred way of doing revalidation. Last modified is also a timestamp. Predictably, it is when the file was last modified. But it's not actually that reliable, and we'll come back to why it isn't very reliable shortly. It's a revalidation header as opposed to a caching header. Date of creation is just a very crude proxy for whether the file is actually changed or not. You could write a file to disk with the exact same contents. The last modified will update, even though the file itself hasn't. You can get a lot of false positives. So those are the three you need to delete. Pragma, Expires, last modified. So which ones do we want? It's really easy, we only need two. Cache control for definite. Cache control is an extensible header, and it carries directives. For example, private, max age, must revalidate. These are all examples of directives. We will look at every directive in a little bit more detail and start to design very bespoke cache policies for different file types and responses. So cache control has been the preferred way of caching things since 1997, which may, at this point, be older than some people in this room, trying to just gauge the situation. And it is highly extensible, which is one of the primary benefits. That's a caching header. This instructs the browser, you can hold on to this file for X amount of time. ETag is how you would ideally manage revalidation. This is how you would tell a browser, the copy of the file you've got is different to the one I have on the server, therefore you need an update. They can look like this. This would be a weak ETag. The contents of the ETag usually looks like a hash. It's usually a checksum of some sort. It doesn't have to be. It could be anything. It just needs to be a unique identifier. Weak ETags are usually going to be a checksum of the file's metadata, and if it's a checksum of the file's metadata, it's not actually much more reliable than last modified. The analogy I use is a weak ETag would be like referring to a book by its title. 2 people, 3 people, 10 people around the world, 10 authors may have all written a book with the exact same name, but it could be a completely different topic, completely different sort of country, language, everything. They might happen to share the same name. A strong ETag is usually going to be a checksum of the contents of the file, and the analogy I use, is more like a book's ISBN. This is a very specific reference to a very specific resource. So a revalidation header, you can have strong or weak versions. Strong ETags are usually programmatically slightly more expensive to compute, so if you do these at build time, that's much more preferable than trying to do them on demand. Which usually means that for API responses, strong ETags probably aren't the best bet, because the just overhead of hashing and adding this header could be a bit much. But for most static assets, certainly a strong ETag would be preferred. All right, let's whiz through a bunch of caching scenarios. We're going to look at all of the different directives we have available and why we might use them, and when. I'm going to present this in some weird kind of faux quiz. I'm going to have some really convoluted, very shoehorned questions that I had to design in such a way that they have yes or no answers. I'm going to ask you a question, a scenario, and if the answer is yes, what cache control header would you have? And if the answer is no, what cache control header would you have? And just discuss it maybe with the person next to you if you think you know the answer. It'll become more apparent now. My question is, can we cache this response at all? If the answer is yes, what kind of, so it's quite small, I'm afraid, I'm sorry, but the top half of the screen is yes. If we can cache this file, what cache control header might we have? What might it look like? Feel free to discuss it with the person next to you. If we can't cache this file at all, if we're not allowed to cache this response, which cache control header would we have? It's not a particularly interactive part of the talk, because I simply don't have the time. But if you think you know the answer, you might use something like this. As simple as that. You just need a max age directive, and this instructs all caches, CDNs, private caches, everything. You can hold a copy of this response for an hour. Every example in these slides is exactly that. It's an example. Don't go copy and pasting these and then emailing me when you've broken everything. We'll go through deciding these numbers later. If this file can't be cached, you would use no store. No store is a very aggressive, very strong directive that simply says no cache is permitted to store a copy of this response. So max age is just a directive that takes a number in seconds, which tells any cache, whether it's a CDN, a proxy, or your own browser cache, how long it can hold onto this file. It's defined in seconds because it's relative, which means we avoid the whole the expires in the past problem. There's always going to be an hour from now, an hour from now. It also makes revalidation more like renewal. You can always add an hour on. The problem with the expires header is, even if a file hasn't changed, you'd have to omit new last modified and expires headers, so you're always staying in front. Give very careful consideration to these values. Like I said, don't copy and paste anything from these slides. No store is a very aggressive directive that says no cache at all may store this response. You may see people emitting headers like this, a very aggressive, very defensive, and somewhat redundant no cache, no store must revalidate. The spec actually says that any compliant cache will take the most restrictive of all the directives so that you don't accidentally cache something you shouldn't do. So all you really need is no store. However, and I don't have time to go into it, but if you buy me a beer, there is one CDN who actually gets this wrong, and if you use that CDN, and it'll cost you a beer to find out who it is, you probably want to add private as well. We'll come back to this in a second. There is a slight loophole in the spec that a certain CDN exploits, which could lead to you leaking data you probably don't want to. Okay, next question. Does this response always have to be perfectly up to date? This is about as close as we can get to caching a file and having always up-to-date responses, but even still not quite. So does this file or does this response have to always be perfectly up to date? If yes, we would lean on the no cache directive. This is a really annoying name. No cache doesn't mean don't cache it. It means don't go to the cache first. You cannot go to the browser cache first. You must first go to the server, see if we can use the file, and if not, don't use the cache, fetch a new file back. Very confusingly named. It doesn't mean no cache. It means no going to the cache before you go to the network. If it doesn't have to be perfectly up to date, you can tolerate a slightly stale response. We would just use a simple max age with a number that we sort of see fit. So the new concept we've introduced here is no cache. The no cache directive, as I say, very confusingly named. It doesn't mean don't cache the file. It means don't check the cache first. Go and see if we've got an up-to-date version. What this means is we can guarantee that the file is always going to be as fresh as possible. Now, we looked at this pattern earlier, where a file, if it's still fresh, we go straight to the cache and release it. This is now impossible if you put a no cache header or directive in the header. So, no cache forbids the browser going straight to cache. It always makes a trip to the server. If the server says, yeah, that file in your cache is still safe to use, you've incurred an entire synchronous round trip of latency just to release the file from cache anyway. I would fairly kind of confidently posit that nearly all responses can be cached for at least a little bit. So no cache is quite wasteful. It will always incur at least one round trip of latency, which means if you end up releasing the file from cache anyway, it may not have been any faster, because most requests on the web are latency bound. Okay, I need to hurry up a little bit. Can this response be shared? This is an interesting one. So when we think about caches, we tend to think about, I've got this style sheet cached on my device. I've got this image cached on my device. We probably want every single visitor to our website to get the same style sheet, to get the same main product image. We want them to see the same thing. We probably don't want them to see the same /my account. We probably don't want them to get the same API response when they click to their latest transactions. So certain responses could be shared, certain ones can't. If a response can be shared, we could use the public directive. It says, hey, this is a public file. Anyone can use this exact copy of the file. Perfect example would be your main style sheet. If the file is sensitive or in sort of some way personalized, so maybe someone's opted into a server-side A/B test, you would use private. Private says this is only suitable for the person that requested this file. Now here's an interesting caveat. Don't use public. Public is implied by the presence of a max age header. As soon as you put a max age header on there, public is implied, which means that shared caches, CDNs, etc. will recycle this response. If you do put public explicitly, you are going to opt into some security concerns. It's a bit leaky. I don't have enough time to go into it in the talk, but again, find me afterwards. Public is implied as soon as you put a max age header. If you explicitly list public, things behind an authorization header can pop into shared caches, even though they shouldn't. Well, not necessarily shouldn't. It's part of the spec, but you probably don't want it. So public, just don't use it. The net effect of public, whether you use it or ideally omit it, is basically a request comes into origin, it passes through your CDN, a copy stays on your CDN and gets passed out to every next user. This is the primary benefit of a CDN distribution. That is useful for things like a style sheet or a product image you want everyone to see the same version of. A response carrying a private directive will still pass through your CDN, but it will not stay there. It's only intended for the requesting party. The client that requested that response is the only person who gets a copy of that exact response. Visually, passes through your CDN, but does not persist. This is where the whole problem with the CDN that I mentioned comes in, because there's a certain CDN that will sort of share these files, even if they're not meant to. Okay, this is where the questions get really convoluted. Can we reuse this response for offline users, even if it's stale? So if you've ever opened your laptop on a flight and you haven't connected to Wi-Fi and the page refreshes, but you still see the page. It's like, oh, I'm not connected, but I can still see the page. That could be a phenomenon whereby the browser has released a file from cache even though it was stale. In the spec, browsers are allowed to release a file from cache even if it's stale in certain scenarios such as you are offline. And that's default behavior. So if you just put a normal cache control max age header, the browser is allowed to recycle files, even if they're stale, if it can't reach the origin server. This is a slightly unusual behavior that you're opted into by default. If this doesn't sit well with you, you can opt out of it very easily by just adding must revalidate, which this says, as soon as we hit that max age of 3,600, an hour, you must revalidate with the server. You cannot recycle or reuse this response once it's gone stale. So must revalidate. Caches are permitted to serve stale content, unless explicitly told otherwise. I'll just nip through this a little quicker. In the spec, it says right there, HTTP allows caches to reuse responses when they're disconnected from origin server, must revalidate or prevent that from happening. Questions are getting weirder. Can we tolerate a slightly out-of-date response while we perform revalidation? Can we have a bit of a grace period? Like, we know the file's out of date, but you can show it for like 10 more minutes? That's good for sort of like images. Let's say you work for a publisher, a news website. The main image is probably not the most important bit of content. It might be, but it's probably just sort of decorational to support the article. In that scenario, you might say, cache all our images for a day, but after they've gone stale, maybe release them for an extra hour as well. And what happens during that extra hour is very interesting. If you can tolerate a slightly out-of-date response, then you would add a stale while revalidate header, and this equates to 10 minutes. If we don't want that, we again just stick with a simple max age. The use case for stale while revalidate is very, very fascinating. Revalidation happens in band. Let's say you've got an image that has gone stale. What will happen is the browser might render the page, but because the image has gone stale, the browser has to go back over the network to the server, get the new copy of the image, and bring it back. And while you're doing that, you've just got an empty gap in the page. Stale while revalidate says, okay, for at least 10 more minutes, put the old image in that place, but in the background, out of band, asynchronously, go and fetch the new version of the image so that the next visit gets it immediately. Matt did a really good example with stale while revalidate this morning, where he used it to get around slow API responses, where you can use a couple of seconds old API response, and during that couple of seconds of staleness, fetch the fresh response in the background. Really powerful, simple directive. So that looks like this. Step 1, release a file from cache, even if it's stale, 200 response, in the background, conditional request, and the appropriate response. Nearly getting there. Do we need to, or do we want to, configure CDNs and browsers differently? I always wondered why on earth someone might want to do this, but it turns out there's a very, very elegant use case. Do we need to configure CDNs and browsers differently? If yes, we would use the S-maxAge directive. S for shared caches, CDNs, proxies. Again, as Matt pointed out this morning, the lack of a hyphen in S-maxAge or maxAge is really quite irritating, not very consistent. But here we can say to our CDN can hold a response for a day, a user's cache can only persist for an hour. If we don't want that, we just use maxAge on its own. S-maxAge answers the simple question, why would we want to configure our public and private caches differently? Cache busting is a myth. This is what I said earlier. Cache busting, revalidation is a thing, we can do revalidation, but cache busting, as we tend to think of it, doesn't really exist. We can't reach into our user's browser and evict their cache. We can't do that. So what we might risk is, I really wish I wish we hadn't used a week-long cache control header. I wish we hadn't used a week, because this is a really important update, but we can't actually reach into our users' machines and evict that cache. We've just got to wait for it to flush itself. So what you could do is you could configure your user's cache to store something for an hour, and the CDN to store something for a day, because you can flush your CDN cache. So what you might say is that the oldest content a user will ever have is an hour, the oldest content the CDN will have is an hour, or we flush it on every deploy. This also serves to shield origin. So users go back to CDN once an hour, and CDN goes back to origin either daily or every time you roll a release. This just means that the kind of tolerance levels can be graded, and the oldest content a user will ever have is like an hour old, and you don't need to come back to origin every hour as well. It's just a way of shielding origin. Last one, is the file hashed? Yes or no? Most people using modern frameworks, modern build steps, will be spitting out fingerprinted files. If you're using fingerprinted files, you immediately get access to something very powerful, which is called immutable caching. If you are using a fingerprint, you can stick the maximum possible max age, which is 2,147,483,648 seconds. Hands up if anyone recognizes that number. Say again? That's what the spec says the maximum possible max age value is. If a CDN, if a cache supports longer than that, go for it. But the spec says that all caches should accept that value. And the directive immutable just means never ever try and revalidate me. If we don't spit out fingerprints, we need to pick a far more conservative value, like I think that might be a week. So immutable makes a contract with the browser. If you fingerprint a file, the contents of the file never changes. You get a whole new file. You might have app.123.css, then you change it, and your build system gives you app.321.css. That file hasn't changed. It's a whole new file. If files never change, you never need to revalidate them. So the beauty of immutable is you can create a contract with a browser that says, cache this for infinity. Never revalidate it, you just don't need to. This file, if it changes, it ceases to exist. So yeah, this number, basically this is the biggest number you can represent in a 32-bit world. It's 0 and 31 ones. If that was 32 ones, that'd be negative 2.147 billion. The spec just says that that's the biggest number you can use. Okay, I do need to whiz through the next bit quite quickly. So we've dealt with caching. We've got a load of different scenarios and answers to the questions, how should I cache this response? Should I cache this response? When those cache lifetimes have expired, what do we do next? Well, what we do is revalidation. One interesting thing I want to talk about first with revalidation is it's technically unnecessary. You don't need to revalidate files. Let's say you've told a browser, cache this file for a week. Once that week has expired, once that week is up, the browser could be very wasteful and just say, well, I'll just fetch the file again. I won't check if it's changed, I'll just fetch the file. You're going to run into a lot of false positives, and that's very wasteful. It's not very elegant. So what we do is we say, okay, my cache lifetime has expired. Do I need to fetch something anyway, or can I just keep using this? So revalidation should be seen as more of a renewal. The naive approach would be simply, this file's expired, download it again anyway, don't check if I actually needed to, just fetch new data. This kind of guardrail means that we can actually check if we needed an updated file. If not, we get the new headers, and we just expand or renew the cache sort of lifetime accordingly. So yeah, this is a mitigation against this kind of wastefulness. So revalidation, we don't technically need it, but it's quite elegant, and it does help avoiding false positives and waste. Let's look quickly at last modified and ETag. We mentioned them briefly. Both cause the browser to emit conditional requests once the max age has been met. So basically what will happen is we'll send out a conditional request saying, hey, is this changed from this hash or from this date? If yes, you'll get a 200. If no, you'll get a 304, and it'll pop back out of the cache. So conditional requests would be if non-match. If you don't match the hash that I've got locally, we'll do this. Or if you've used last modified, it'll be if you've got a date different to mine, then we'll do this. If it resolves to true, you get 200, download a new file. If it resolves to false, you get a 304, you're redirected back to your browser cache. Of the two, you would prefer ETag. As I said before, just because a file may have been last modified doesn't actually mean the contents have changed. Zach's going to swing for me when I talk about this. I don't use 11t. I've got a super old school setup. I use Jekyll, right? I use Jekyll on GitHub Pages. And Jekyll on GitHub Pages is a very, very naive kind of static site generator. If I fix one typo in one blog post, GitHub Pages rebuilds my entire site. And it gives all the files on my site the exact same new last modified. I've changed one typo in one blog post. I just cache busted my entire site, which is why I tend to leave my site full of typos. It's a performance thing. Just to demonstrate the problem, this isn't exactly how it works, but if I just write the string hello world to a file called revalidation, I catch its last modified, it was 18, 37, and 50 seconds. The checksum started with 6F5902. I then write the exact same string to the exact same file. The last modified is updated, the checksum hasn't. These are the false positives you risk running into if you use last modified over ETag. This is the exact kind of thing that would happen to me on my site, because by default, because I'm not fronting it with Netlify or I'm not using Cloudflare workers or anything, I've got a very naive setup. I would run the risk of getting loads of false positives and effectively cache busting my site anytime I change even the slightest typo. Finally, don't revalidate your hashed responses. On the subject of revalidation, if you've got fingerprints in your files, don't emit ETag headers at all. You just don't need them. If the file is never going to be revalidated, you don't need revalidation headers, so it simplifies it even further. So I'm going to rush through this last bit really quick because I've been given my 0-minute warning. What have we learned? Hopefully, quite a lot. We shouldn't expect to be able to fetch new content while a response is cached. Those two concepts don't marry up with each other. We only have two jobs, caching something and revalidating something, therefore we only need two headers. The fact we've got 5 potential headers to use just leads to confusion. We need cache control, and we maybe need ETag. In certain scenarios, we only need cache control. We don't need ETag at all if we've got fingerprints on our file names. Expires and last modified aren't bad, but we should prefer cache control and ETag. And again, files that never change never need to be revalidated. The last thing I'm going to leave you with is some little cheat sheets. This one I'm not going to have the time to actually discuss. I'll post a link to the slides. This is just the general finger in the air kind of way of deciding how you would set your max age values. Put file types into buckets. This never needs caching. This updates semi-frequently. This never updates. Whatever you choose, that will be your kind of brackets. And you might cache for periods of hours, seconds, weeks, never. And finally, if you've got non-versioned assets, you will need a cache control header, you will need more granular cache control directives, and you will need ETag. The moment you put a fingerprint on that file, which your build step has done for you already, you still need a cache control header with an immutable directive, your maximum max age, and no ETag whatsoever. All right, so that was a very, very, very quick run through everything you wanted to know and probably more about caching. Thanks for listening. I hope you got something out of that. And yeah, I'll take questions, I suppose. Thank you very much.
Cheers, Harry.
Oh,
Thanks for that. Have a
that was
seat.
a bit of a sprint.
All right. That was a lot.
Well, yeah, because it's a 30-minute talk, and that was 45 minutes worth of slides.
Yeah. Kind of sounded like that. You and Chris actually do a good job of seeing who could talk faster. No, that was a good comparison. So we have a few questions coming in, and first and foremost, testing. What tools and strategies do you recommend for testing the caching that you're setting up?
Turn off the disable cache option in DevTools, because that'll really trip you up. Most performance engineers will have disable cache permanently enabled, and that's why your caching strategy is hard to debug. So make sure that is disabled, make sure you're caching, make sure that button isn't checked. I could live code it, but I won't. You know, in the network panel of DevTools, you've got the filter bar. You can put in there status code, you can filter by status codes. So what I would do is when you're debugging your caching strategy, in the filter bar where you're normally used to searching for file paths and strings like, oh, is this site using jQuery or are we using Nuxt or whatever, you can actually search on metadata by using predefined filters, minus status minus code colon 200. I'll tweet it or I'll just find some way of getting it to you. You can filter on everything that isn't a 200 response and then scope it to your own first-party content and just browse around the site. And all you should ever see is 200s. If you see any 304s, that might be a genuine revalidation, but you can go and look into it. It also flags things like 404s and other unexpected response codes. So basically, in DevTools, filter every non-200 response, and then web page test. That when you script a test with web page test, ensure you do first and repeat view. Look at the repeat view, and if you get lots of yellow, like someone's got highlighter and highlighted loads of entries, that is redirects, and 304 is a redirect response code. If you do a repeat view, you see an unusual number of yellow entries. That's because someone's refreshed the page, and for some reason, loads of files got revalidated. So DevTools, filter by everything that isn't a 200, and web page test, run a repeat view, and be wary of any yellow entries that you find. That's the easiest way to start.
Awesome. That's great. Now, things that trigger it. So one of still the most frequently accessed things in any web browser is the back button. Is that something that is also going backwards and forwards? Is that still going to trigger the same checks on the cache headers?
Oh, this is a really good question. So we've got something called the back-forward cache, which is separate to the HTTP cache. So in the olden days, you'd hit the back button, and the browser would rebuild the previous page. It would fetch the HTML from wherever was necessary. So if the HTML had a no-store response header, the HTML would be fetched from the network. If the CSS had a must revalidate directive, it might be fetched from the network. So traditionally what would happen is hit the back button, and the page would be built just like you'd gone straight to the page anyway, right? All the caching headers would be honored. Nowadays, all modern browsers have something called the back-forward cache, and eligible pages are stored in memory. You hit the back button, and things don't even come from browser cache, they come from memory cache. It's instantaneous. There was one thing that would prevent that from happening, and that was if the HTML response had a no-store directive in there. It would be ineligible for back-forward cache. The reason for this is a true sort of anecdote. True anecdote, it's a true story. They're rolling out tests to see if like, our page is faster if we just load back navigations from memory cache. And a bank in the US that gave their customers iPads, someone had hit log out, and they'd gone and logged out. A next customer came along, this is a true story, although I can't prove it. You can read it in the Google documentation for why they banned no store from back-forward cache. Someone was able to hit the back button, and the previous customer's bank details, that like logged in state, was restored from memory. There was no honoring of the no store header. Actually, yesterday, Google published something saying that they've experimented with allowing no store back into the back-forward cache. So as of yesterday, don't log into your banking on a public machine. So yeah, that's a long answer to a short question. Did I even answer it?
No, I think you did.
Yeah, so basically, the back-forward cache, the BF cache, is instantaneous page loads. As of pretty much today, even no-store responses can be restored from memory. Should be very careful, I suppose.
So that leads on to a question of space. We know that sometimes your page might be delivering a fairly large payload. You might be caching an awful lot of stuff. What are the limits? What do we have to worry about when we're caching things in the browser?
This is a very, very... Whoever's sending these questions in is great. So there's no spec for how cache purges should work. So browsers don't necessarily purge cache by largest files. It's not a last in, first out, or first in, first out. They don't purge by origin. So what would be nice and safe is if your browser's thinking, oh, I'm getting a bit full, I'll purge all of CNN.com's files. So that, but you could run into scenarios where half the files may be coming from cache for that page, and half might be coming from the network. There is no specification that dictates how cache purging works. It's not to do with size. It's not to do with origin. There is no real rhyme or reason, which makes it doubly important that you have your sort of cache control headers set up correctly, because you might have overly aggressive headers on some files that don't match up with others, and you can run into real pain.
Okay, I've got a really esoteric question to ask. That's just satisfying my own curiosity. Okay. But I want to ask one other one first. For those of us in the room who are maybe earlier in our career, what would you give your younger self if you were to learn about performance from scratch? Where would you start?
Oh, okay. HTML is fast. Do as much as you can in HTML. We love HTML. It's just fast. Browsers like HTML. People like HTML. Anything very important should be coming from your HTML. So I'm not saying JavaScript's bad. I'm not saying it's good either. But yeah, HTML and understand browser internals. Nearly every dollar I've ever earned in my sort of consultancy career has been just knowing fundamentals. I've spent the last 5 or 10 years taking the edge off of JavaScript applications. Lean on the platform as much as possible. The platform is fast. The platform has its own optimizations that are just inherently faster. Honestly, in a 2 words, browser internals. Learn how browsers work. You know,
that's really interesting, because Waldemar and I were just talking earlier about what would be a useful talk for designers, and one of the things that we talked about was the life cycle of a page request. And understanding that better as a designer, and I'm sure as a developer, is just massively interesting and useful stuff to know when and where things are going to happen.
Yeah, so very dear friend of mine, a guy called Tim Cadleck. I've never seen him do it, but he told me he used to run a workshop where he'd get post-it notes, and he'd write on the post-it notes all the different parts of a page load lifecycle, from someone hitting enter on their keyboard to the page being on the screen, and he'd give out these post-it notes to the attendees of the workshop and say, right, go and stick these collaboratively, stick all these post-its in the order you think the browser goes through between someone hitting enter and them seeing, like, the main image. And I think that's a really great model for learning that, a very tactile way of doing it. I might steal that one. It's a very, very good learning mechanism or method.
So the last question, we've hit our 0 mark. I'm just going to ask the question because I think it relates to this. We may not be able to dig into the answer entirely, but one of the things that I've always built into some of the projects that I work on in terms of testing support for variable fonts, for example, loading something from cache and knowing that it's there seems to be noticeably slower than simply setting a variable in local storage to tell me whether or not it's supported. And for some reason, that has helped me avoid that flash of unstyled text more by just skipping the browser checking the cache and looking for it, but telling it it's there. And I thought it was a really interesting distinction about, don't go look, just go find it. I know it's there.
Yeah, so I don't know the exact phenomenon you will have experienced, but it is certainly true. And Akamai ran tests on this. There's a thing in Firefox internals, and they were measuring, I think it was like race network against cache in their internals. Someone found this. And in certain scenarios, doing a file system read, while the browser's doing everything else it's doing, Firefox used to race the network with a cache lookup. And sometimes they did it purely for heuristic purposes, just like telemetry. They found that in a surprising 16% of cases, it was faster to just go to the network, fetch the file, rather than root around in the cache.
Wow.
I don't know if you've hit a similar phenomenon, but...
That's fascinating. Well, thanks for indulging me. Got that last one in. Harry, thank you so much. This has been fascinating.
Thank you all for indulging me. That was a bit of a sprint, so I appreciate your time. Thank you very much.
All right.